Good morning, or whatever time of day it is you view this recording. This is a beginning algebra recording for 4.1, 4.2, and 4.3. We are now on a new experience. What you see in front of you is the assignments we have so far on Chapter 4. We will only do sections 1, 2, and 3 of Chapter 4. Okay, Section 1 is graphing to find the solution of a system of equations. Lesson 2 is substitution to find the solution of the equations. Lesson 3 is using elimination, in other words, eliminating one variable to find the solution of an equation. Chapter 1, or Lesson 1. Okay, Stephanie, I goofed up. Lesson 1 on graphing is where we are graphing two lines to see their intersection. And on 4.1, number 13, I have 13 done right here. Now remember, x plus y equals 4. You've got to get the y by itself. And then the number in front of the x is your slope, which is negative 1. Negative 1 over 1 is your slope. And then the other number, your 4, is your y-intercept, 0, 4. So we first go to 0, 4, put our point there, and then from there down 1, 1 to the right, down 1, 1 to the right, and keep doing that. I'm lucky enough to have graph paper at home, so I graphed it. The second equation, we had negative y equals negative x plus 2. Remember, we had to divide out that negative on the y, because y has to be by itself. We divide out the negative 1, and then negative 1 into both terms changes the sign of all three terms. So y equals 1x minus 2. So our slope, the number in front of the x, 1 over 1, and our y-intercept, 0, negative 2. So we go to negative 2 on the y-axis, our y-intercept, and up 1 and 1 to the right. Our second equation, number 15, is x plus y equals 6, and negative x plus y equals negative 6. Notice the work there. Because of time, I do not have time to explain each problem. So then we go on to problem number 17. Y equals 2x. We already have the y by itself. Excuse me, that's number 17. That's the problem you do. Number 18 is y equals negative 3x. The y is by itself, so the negative 3 is our slope. Negative 3 over 1. And the y-intercept, there is nothing out there beside the negative 3x, so 0, 0 is your y-intercept. So we start at 0, 0, and then the slope being negative 3, I went up 3, left 1 to get that slope, and I also went down 3 and to the right 1, and you can keep doing that many times. The second equation, negative y equals negative 2x minus 5, I had to divide out the negative 1, making my slope 2, and so on. And so I graphed that one. Remember, you can pause this film and look it over and go to the work. Then 19 and 20 are shown here. And of course, you are to do the odd ones. Then excuse me. Then we go to 4.1. I did some extra ones here that you can look at. 21 is the first one there. It's an assigned problem. 2x plus y equals 0 and 3x plus y equals 1. They're pretty close together. Their slopes are pretty much the same, so it takes a little while to find their intersection. The number 22, 2x plus y equals 1. Remember, you got to get the y by itself and find your slope. Second one, 3x plus y equals 0. You've got to get the y by itself, as I did there, and I graphed both graphs here in the picture. Remember, you can pause and look at this. Then 23 and 24, here's 23, which I didn't work. That's for you to work. 24, the y is already by itself, slope's 1, and y-intercept 0, -1, and here's where it's graphed. Then the second one, y equals -3x minus 5, is here, and the slope, -3/1, and y-intercept 0, -5. Remember, we're looking for where these two lines intersect, as I've shown here. Then 29. 29, I started working it out. The first equation is x minus 2y equals 2. I started doing some work on it, not remembering that it was your problem. And then there's the second equation, 3x plus 2y equals -2. Then number 30, x plus 3y equals 7. And then my work shows how to get the y by itself. Second equation, 2x minus 3y equals -4. And then my work to show how to get the y by itself. Then I showed the graph of this. And then I went ahead and did 27, even though, well, I had put it down, but I did 28 because it showed a vertical line, x equals 4, and what you do, the other line, x plus y equals 5, and how you had to get the y by itself. It wasn't assigned, but I went in and did it. 31. 2x plus y equals 4, and 6x equals -3y plus 6. 32, y plus 2x equals 3. Remember, get the y by itself and work it out. The work is shown here. Second equation, 4x equals 2 minus 2y. Again, I flipped the equations around, put the 2 minus 2y on the left side, equals a 4x. Then I moved the 2 to the other side by subtracting. And then I divided by -2. All the work is shown here, and then I show the slope, -2/1, and the y-intercept 0, 1. I graphed both lines, and as you see, they are parallel to each other. And then section 4.2 is substitution. Remember, this is where we substitute something in for one variable. X plus y equals 3 and x equals 2y. From the second equation, x equals 2y means 2y can be put in for the x. So I put 2y in for the x in this first equation. I've got the equations numbered here so you can see what I've done. And then by substituting that 2y in for the x, now we have 2y plus y equals 3. And so 3y equals 3, and we find the y, and then we put that y value back in one of the equations above and find the x. And this is how you write your answer. Number 2 is reworked here, which we did in class. Number 3, another substitution, x plus y equals 6, and y equals -3x. So -3x is going to replace your y. The work is shown here, where you can pause and look at it and follow it along and write it down. Very important. Then number 4 we did in class. The work is shown here again. Then number 5. Y equals 3x plus 1 and 4y minus 8x equals 12. And number 6, y equals 2x plus 3 and 5y minus 7x equals 18. From the first equation, y is by itself, so I substituted 2x plus 3 in for y in the second equation, as shown here. Then the work is following along here, which you need to follow along and see what is done. Then, question 7 is shown here. Y equals 2x plus 9 and y equals 7x plus 10. Number 8 is like that, shown here. And so I substituted 8x plus 4 in for this y up here. And then I have this equation. Okay, then I went through the work of getting the x by itself, which we have a fraction, negative 7/3. So negative 7/3 is put in for our x in one of the original equations, as I show here in equation 1. And here's the work. And remember, since I was dealing with fractions in an equation, I can multiply by the common denominator, 3. Then that's shown here, and I found another fraction. Okay? Question number 9 is shown here. And 10, here's the two equations, is shown here. Remember, pause and write these things down. The video doesn't have time to go into detail on each. Number 11, here's question 11. No work shown on it because here is 12. X plus 3y equals negative 5 and 2x plus 2y equals 6. And so I had to get, there wasn't a variable by itself in either equation. So I put the easiest variable by itself, which is x, from the first equation. X equals negative 3y minus 5. And then that negative 3y minus 5 can be substituted in the second equation. And we work it out as I've shown here. And I find y. And then I came over here and found x. Question 15, here's the equation. Question 16, here's the two equations. And remember, I had to get a variable by itself, and the easiest one to do is the x. Here's the work shown here. Please follow through and find it as I've done there. Question 17, here's the equation here. 18, here's how I did it. Again, we needed to get a variable by itself, the x. Follow the work here that I put in, and that's how you do 18. (19), here's the equation, and 20, here's the two equations. Remember, I had to get a y by itself, and then I substituted what I found for that y in the other equation. Remember, you can pause and work this out and follow the work. 21 is an equation that is not simplified at all, so you need to simplify it. As I did on 22, I had my two equations. 5x plus 4y minus 2 equals negative 6 plus 7y minus 3x. So I simplified that by moving the x's to the left side, by moving the y's to the left side, and by moving the constants, the negative 2 and the negative 6, to the right side. Same way on the second equation. I moved the x's, combined them, 3x and 4x, 7x. Minus 3 equals y, and that gets me a y by itself that I can use on substitution. That was from equation 2. So from that equation 2, y equals 7x minus 3, I put that 7x minus 3 back in equation 1 for the y value, and then here's the work that I followed through. Then, on lesson 4.3, it's elimination. Remember, that's adding to eliminate one of your variables. Here's question 1, 3x plus y equals 5, and 6x minus y equals 4. By adding those equations together, we get rid of the y, and so we can find the x. The work is shown right here. Number 2, 4x plus y equals 13, and 2x minus y equals 5. By adding those equations together, we get rid of the y's, and so we can find the x, and then we substitute it back in. Question number 3 is x minus 2y equals 8, and negative x plus 5y equals negative 17. We can add them together and get rid of the x's, and we find the y, and then substitute it back in to find the x. Number 4, x minus 2y equals negative 11, and negative x plus 5y equals 23. We add them together because we get rid of the x's, and so we find the y and substitute that y value back in and find the x.